Hi guys, a pleasant day to the viewers of this video. This video will discuss one example of a definite integral of an absolute function. So an absolute function is a function with this form over here, or yeah, so basically the function of x that we have is an absolute function. This means that whatever value of x you place here, the absolute value bars will make the final answer of the absolute function equal to 0. So what makes this absolute function special? So basically, the absolute function is represented by two functions. One wherein um, the equation follows a certain pattern and another equation that follows a certain pattern. So to demonstrate what I mean, technically an absolute function is an example of what we call as a piecewise function, wherein it can represent two types of functions depending on the ranges of x that you are referring to. So to form an absolute function, basically you just write two functions, mainly the negative equivalent of the entire content of the function inside the absolute value bars and the positive content of the absolute function. So that's it. And given that this is a piecewise function, if you have heard what a piecewise function is, it's a function that is composed of two parts, two or more parts. And the composition of the piecewise functions depends on the values of x that are plugged in to it. So depending on the value of x, you need to use a particular value of the function. So to get the ranges of x that hold each of these piecewise functions true, what you need to do is just equate the content of the absolute function, equate it to 0, and then that's the time you will get the value of x, which represents the boundary between these two piecewise functions. So to get the value of x, if x plus 2 is equated to 0, you do transfer this value over here, the 2 here, and then you will get the value of x is equal to negative 2. So what does this mean? If the value of x is less than, I think the value of x is at negative 2. So values that are less than negative 2 are negative 3, negative 4, negative 5, and so on and so forth. The function of x that you have to use is, or the function that you have to use during the plotting and the substituting of values is this one. Okay? And if the values of x are greater than or equal to negative 2, then you need to use the value of this one. Okay? So that's how you create a particular, or that's how you create the piecewise function of an absolute function. So later you will find out during the process of getting the definite integral of an absolute function, this or these values or these functions rather, the one I wrote here, and then the one I wrote here, this will be very essential soon in getting the differential equation of an absolute function. I think I said definite integral. Okay. So I hope I said that. Maybe I blabbered some words which is not related to the definite integral. But anyway, so what's the next thing that we're going to do here? Um, remember that the function itself is a piecewise function. It means depending on the values of x, a particular function should be applied. Okay, so what do we do with it? During the process of definite integration, you have to be mindful of the entire piecewise function because it will dictate what specific function should we use and what particular limit should bound or should bind the or should cover that entire particular function. So remember that our given here is the definite integral of the absolute value of x plus 2 with respect to x from -5 to +4. Okay, so we're going to rewrite that one. So we have -5 to +4 absolute value of x plus 2 with respect to x. Now, you have to take note that the limits are basically ranges of x, wherein we need to consider the range in such a way that it should match the conditions in each of the piecewise functions. For the first function, this first function will hold true the negative of the quantity x plus 2 if the values of x are from any value of x that is just less than -2. Okay, but for x, but for the positive side of the absolute value function, so the values of x must be equal to -2 or greater than -2. And if you look at the limits, so if you're going to write here the limits, we have here -5, that is the lower limit, and we have +4 as the upper limit. So what does that mean? It means that in between the two is the value of -2, right? And again, this -2 is crucial since it will dictate us or tell us what value or what function rather should we integrate on depending on the range of the values of x. So in this case, since we have -5 and from -5 up to -2, the portion or the section of the absolute function that we need to integrate should be this one. So again, because of the fact that the piecewise function of an absolute function is like this, we need to focus on the negative x plus 2 within the range of -5 to -2. However, from -2 to +4, the condition of x greater than or equal to -2 holds true, which means that for this case, the positive equivalent of the absolute function should be integrated. Okay? Should be integrated in order to um, make the integration valid. Because then again, the absolute function is composed of two piecewise functions. So that will be our consideration for the next steps during the integration. Because again, you cannot integrate the absolute function right away by just removing the bars. So what you are going to integrate later are these functions here. And of course, they are based on the range. So now, to do that, we have what we call in integral calculus the term additive interval property. So the additive interval property states that you can actually break down an integral or an integration of a particular function with lower and upper limits into two parts. So in this case, if you have an integral of a function of x with respect to x from a to b, you can actually break it down into two integrals of the same function, but your limits will be from the lower limit up to a particular intermediate na limit. So this intermediate limit is the one that you have to set that should be in between your a and b. So the intermediate limit or the middle limit, which is c, should be the upper limit for the first integral. And then for the second integral, the middle limit of c should be the lower limit, followed by the upper limit of b. Integral of f of x with respect to x from c to b. So you are just basically breaking down the entire integration into two parts. But this time, you have to declare a particular value of c that is in between a and b. So in the context of our word problem, or not really word problem, numerical problem today, in this case, our lower limit is basically our a, and our upper limit is basically our b. So of course, the letter c here should not be obtained just anywhere, or just randomly obtained. You have to solve it also based on the conditions here. As far as the absolute function is concerned, to get the middle term of the absolute function, or the middle value of x that will separate the absolute function into two parts, just equate it to 0 and then get the value of x. So basically, this is the variable c that I am referring to, or the number c that I'm referring to conduct the additive interval property. Okay? So that is what I mean here. So we are going to apply the additive interval property to integrate the absolute function that is given here in this example. So to continue, so therefore, the integral of the absolute function of x plus 2 with respect to x from negative 5 to positive 4. Okay. So what we're going to do here, class, is we're going to split it into two integrals. The first integral should be the integral of this term, since this term will only be true if the boundaries are less than negative 2 and negative 2. So we are going to write the entire thing. That includes a negative sign. So we have negative x plus 2 with respect to x from negative 5 to negative 2. Okay. That is the first fragment, or the first section according to our additive interval property. The second one is the integral of the other function, which is positive x plus 2. So the positive x plus 2, or you can just erase the positive since it's given that it should be positive inside the integrand. Positive x plus 2 with respect to x. And then we have negative 2 and positive 4. Okay? So basically, you will be integrating two integrals for this example. So this one, we can call it integral A, and we can call this integral B. So later, we are going to add the values so that we can easily find the answer. So for now, to also conserve space and focus ourselves easily on the processes per integral, we will just assign this one with the letter, and then let's focus on each of the letters. So the integral of negative x plus 2 with respect to x from negative 5 to negative 2. So what we're going to do here, class, is of course to distribute the negative signs first. So we have negative x minus 2 with respect to x from negative 5 to negative 2. So what we will do after is to integrate it term by term. So we have integral of negative integral of x. So I just place the negative outside. Integral of 2 dx. Okay. So you can just not write the upper and lower limits for the meantime for you to have an easy way of integrating it without the hassle of the rewriting a lot of upper and lower limits. And then after that, you apply the power rule. So you have negative x squared over 2. So at this point, I will now be doing the fast hand version of the power rule. So I will not be anymore doing the slow step-by-step process, which you can already do at this point. And then minus 2x. So for this one, I brought out the 2 and then integral of dx. So if they are beside each other, the integral sign and the d, they will be cancelled out. And then I think you're done. Negative x squared over 2 and then minus 2x. Then you are going to substitute negative 2 and negative 5. So remember that you are going to write a long bar and write negative 2 and negative 5 as the upper and lower limits. Okay, and then you apply the fundamental theorem of calculus. So if you can recall the fundamental theorem, so the fundamental theorem states that the integral of f of x with respect to x from a to b is equal to the difference of the final answer substituted to be minus f sub a. So that's what we're going to do here. So in this case, we have, oops, negative x squared. So we have upper limit first, negative 2 squared over 2 minus 2 times negative 2 minus, we have here minus negative 5 squared over 2 minus 2 times negative 5. Okay, so we're going to solve for this one. So for a while, negative 2 squared over 2 minus 2 times negative 2. You have here 2 minus negative 5 squared over 2 minus 2 times negative 5. So I have here negative 5 over 2. So 2 minus negative 5 over 2, that is equal to 9 over 2. So this is my first answer for A. So I'm just going to place it here so that I will not forget. Okay. So for letter B, we will solve the second fragment of our entire integral. So for letter B, so integral of x plus 2 with respect to x from, remember our limits are not the same as the given, but we have to start from negative 2 as our lower limit and positive 4 as our upper limit. So negative 2 as our lower limit and positive 4 as our upper limit. So you do the same thing again. So you can split the integrand into parts, the x, and then for this one, you can bring out the 2. So we have x squared over 2 plus 2x. So cancel, cancel. Yeah. And then you write here the long bar on the right side, copying the upper and lower limits. So you apply the substitution process. So we have, okay, let's substitute first the 4. So we have 4 squared over 2 plus 2 times 4. And then minus, um, for negative 2 this time, negative 2 squared over 2 plus 2 times negative 2. Okay, so let's solve for this one. 4 squared over 2 plus 2 times 4. We have 16 minus negative 2 squared over 2 plus 2 times negative 2. We have negative 2. So 16 minus negative 2, so we have 18. That will be our final answer for part B. 18. So our answer for the definite integral, so we are now done getting the final answer, the answers for each of the sections. So the final answer will be the integral of x plus 2, with respect to x from negative 4 to positive 5. Am I correct? Negative 5 to positive 4 di ay. Bali. Negative 5 to positive 4 is equal to um, 9 over 2 and 18. So 9 over 2 plus 18. And so the answer is, you have 45 over 2 or 22.5. Okay. All right. So that is the answer. That is the answer for the definite integral of an absolute function. So what is the graphical representation? So there's actually a graphical representation for the integral. So you might wonder, why am I doing this? What is this for? Of course, when you become an engineer soon, you will be using integral calculus to look for the areas of uh, regions under the curve. Okay, so basically, when you draw the drawing of an absolute function, this is how it looks like. So this is just a rough drawing, okay? So for the absolute function, I think we're going to, or we need to copy this one. Oops, there. Oh, if I place that here, ano siya? I'll just, all right, there. Okay, I think this will do. So, remember that an absolute function is a form of piecewise function wherein it's composed of two functions. So, again, our boundary value of x is equal to x equals negative 2. So, if we're going to plot that one, we actually have that one here, negative 1, and then we have negative 2, negative 3, and negative 4. So we have negative 5, right? Okay, negative 5. Okay, so we have negative 5, and so on. So this is our boundary uh, for the piecewise function. So on the right side of x equals negative 2, we have a different function to draw. And on the left side of the absolute function, we will draw another thing. So if the value of x is negative 2, so let's say negative 3. So for example, if x is equal to negative 3, then we need to use this first piecewise function here, right? So we're going to write that one here as if x is negative 3, then your y is function of x is equal to negative of negative 3 plus 2. What is it? So it's negative 3 plus 2. So negative 1, and the negative of negative 1 is always positive 1. So the answer of the negative 3, because if you put more negative or if you put decreasing values of x, therefore, or that is negative values, the f of x will become negative. But because of the negative sign placed here, the answer will turn out positive. So that makes the absolute function absolute because of this side of the piecewise function. So if you have x equals negative 3, your y is equal to 1. So let me put that one here, 1. Let's put it 2, 3. So that will be your function there, negative 3, 1. And remember, if your value of x is 0, regardless of what function you go to, the first function with a negative sign or the second function, you still get the value of 0. Oops. What I meant was x equals 2. So f of x is equal to x plus 2. So negative 2 plus 2, that will be equal to 0. So that will be your boundary for the absolute function. But if x equals 3, that will be positive value. So your f of x is the positive version of x plus 2. So therefore you have 3 plus 2, that will be equal to 5. Okay, so let us write that one here. 1, 2, 3, 4, and 5. But we need to have 4 and 5 here. So let's connect 4 and 5. Okay. So if x is equal to 3, then our y is 5 there. So basically, if we're going to make a line, this will be the graph for negative x plus 2. That will be the graph for negative x plus 2. And the graph for the positive x plus 2 will be from this line to this line. So remember in basic algebra, you can make a line using 2 points. So I'm just using 2 points here. So this will be the drawing for positive x plus 2. Okay? So now, where is the integral there? Where can I find that the integral of the first fragment, I mean this one, how is the integral represented in the drawing? And the second integral. So actually, class, the integral of a particular function, the integral of a function in reality or in the actual sense is the area under that function. So that is why na later you will appreciate na ang kaning integral calculus, it's actually useful to get the area under the curve or under the function. So in this case, di ba ato ang boundary is from -5 to the first boundary is from -5 to positive to -2, di ba? So where is that located? It's located here in this here. From -5, x equals -5 to x equals -2. So there is a point. So the area under that curve is basically this one. So we have actually solved for the area of the region under the function -x plus 2. So what is the value of that area? So we can call this one as area 1. The value of that area 1 is the one that we solved earlier. Kani siya. Katong first value, no? That is 9 over 2. And the units for that one is square units. Okay, umta ka ba sa units ani, no? Square units. Now, how about for the second area, kaning 18? Remember that the boundaries for the second fragment of our integral range from -2 to +4. So it's kinda wide iyahang coverage, no? From -2 to around +4. So we might need to extend the function. Ana. So let's extend this one. All right. So that is basically the area. So I will shade this one with a different color. So let's use green because Christmas is near. So there. This entire area here is basically equal to 18 square units. This is the second area. So we have here area number 2. So the area under, so the under of ubos, no? Or below this function over here is area number 2, which is equal to 18 square units. Okay, please neglect the exclamation point. You might follow what I wrote. Okay, so that's it. So the total area of the entire absolute function within the boundaries from -5 to +4 is equal to 9 over 2 plus 18 square units. Okay, so in the engineering application, this will be useful soon in many different practices. So usually, for example, in civil engineering, you might need to find how much force is distributed per square area. So you need to know the area of a certain region in your building, but maybe that region in your building does not follow the usual shape of a rectangle. It does not follow the usual shape of a triangle or the normal shapes that you have learned in your younger years. So that's why the integral calculus will be useful for those cases to get the area under the curves or the functions. So basically, it's not a curve here, but it's a line. But again, a line is a form of a curve. Okay, so I hope you are aware of that. All right, so I think that will be all for my video. I hope you learned something, and I will see you in my other videos related to this subject. Thank you so much for watching, and I'll see you soon. Bye.